Today I'm going to try to replace myself with an AI. I'm going to train a digital twin of myself and turn it into an AI tutor that we're then going to embed into a Flask application where we can do live calls with this AI tutor, and we can also send questions to it and get video answers as a response. So let us get right into it. Alright, so the goal of this video today is to clone myself, to create a digital twin of myself and turn it into an AI tutor, and I'm going to do this by using Tavis. So tavis.io, you will find a link to them in the description down below. They're sponsoring this video today, and they offer this all-in-one service where you can create replicas of yourself, you can give them personas, you can generate videos with these personas, and you can also have live calls with these personas. So it's basically you're cloning yourself, and then you can give some context like you're a teacher, you're a narrator, you're a tutor, you're explaining something, you're making jokes, whatever. And then it's going to take this persona, take your replica, and allow you to talk to yourself in a live call, or to talk to yourself asynchronously with video answers. And the coolest thing is you can embed all of this into your Python applications. So we're going to start by creating a replica of ourselves. Now, since this takes some time to complete, it takes like 3 to 4 hours for your replica to actually be trained. I already did that in advance. I'm going to show you what this looks like here in a second, but basically you click on create replica and you just follow the process. I, Neural 9, am currently speaking and give consent to Tavis to create an AI clone of me by using the audio and video samples I provide. Alright, now since I'm trying to build an AI tutor and I'm not trying to just read off some text because I'm not going to be a narrator, I'm not going to be a motivational coach, I'm going to be someone who teaches you to program. I'm going to teach you some concepts that are difficult to understand that you want to explain in. Alright, so it's the next day and we're going to take a look now at the replica library. Here I have now 2 replicas of myself. One is not very good because I used accidentally the wrong microphone. The second one is better, at least when it comes to the audio. Let us take a look and let's listen to it. You can reference your replica and begin testing scripts right now. Our vision is to personalize. Now, I personally think there is a little bit of an uncanny valley here. It's not exactly like the original. The sound is decent. The animations are a bit clunky. Maybe I also recorded it suboptimally. But what we're going to do now with this replica is we're going to create a persona on top of it. So this is the basis. And here now we can create a persona based on this replica. So I can click here. I can select the replica and I can give it a name. For example, let's call it AI Tutor. We're going to say now, you are an AI and machine learning tutor. Your job is to explain complex subjects in a simple and understandable way without sacrificing details. And we don't really need a conversational context because I think that's for the individual conversations. But let's choose a language model here. We can choose Talvos Llama. We can go with GPT-4o, which I'm going to choose here. We can go back. We can also, by the way, add tools if we want to. I'm going to just keep it simple here and not add tools. Then we can choose a perception model. I'm going to leave the default here. We can choose a speech-to-text model. I'm also going to use the default here and a text-to-speech model. Here I'm not sure which one is the best. I'm just going to go with the default too. And then we can create the persona. Now my camera is blocking the view, but there's a pink button at the bottom right here, create persona. I'm going to click that button and now this is processing my request and creating the persona. So there's a couple of things we can do here. We can set up a conversation, or again, my camera is blocking the view. Maybe let me move my camera to the left here. You can see there's also a join now button. Now let me put this to the bottom left. There you go. So there's also a join now button, which I assume starts a live conversation. Let's try to see what happens here. We create a conversation for you. So now I'm going to be talking to myself, I guess. Oh, I'm joining the meeting. Now, I hope I don't have to use my camera because then I would have to stop recording. As a microphone, I'm going to use this. Let's see. Oh, hello.
Hey there. How
Oh, this is
is everything okay? What's up?
Yeah, I was wondering if you could explain to me the concept of backpropagation because I really don't understand how it works.
Sure thing. Backpropagation is a key part of how neural networks learn. Think of it like this. When you're training a neural network, it makes predictions based on the input data. Initially, these predictions might be way off. Backpropagation helps the network improve these predictions. It works by calculating the error in the predictions, the difference between the predicted values and the actual ones. The goal is to minimize this
Okay.
error.
Let's leave the conversation. Now, one thing that I noticed right away is when the replica or the persona is listening, it looks exactly like me, also in terms of how it looks, like the way the face moves. I don't know what the words in English, but that is very accurate. When it's talking, I think the movement is not exactly optimal, but maybe I just have to move more when training the model. I would also like to explore now individual conversations, and then we're going to go into Python and build something around it. So I'm going to go here and I'm going to click on create conversation. I'm going to choose my AI tutor here as a base. I'm going to say, I don't know, let's talk about support vector machines. I don't need a greeting, but I'm going to say this conversation will be about support vector machines, SVMs, and how they work in detail. So then we have a max call duration. We have, I could apply green screen. Let's do that. Let's see what happens. And then let's go with, actually that's fine. Let's go with create conversation. Okay, I again have to join a conversation, so it's going to be live again. Let's see what happens. Okay, actually this was the wrong tutor, I think. Okay, I think I selected the wrong tutor. Let's try again. Oh yeah, because I also need to select a replica. So the replica is not the persona, obviously. Hey, what are we going to talk about today?
Hey, today we're diving into support vector machines, SVMs. It's a cool topic if you're into machine learning. Ready to get started?
Okay, so let's quit that. And one more thing that we can do here is we can generate video. So I can go and say, give me the replica, and then say something specific. So for example, I could say, what is going on, guys? Now, of course, the energy is not going to be the same. I mean, there's a reason the original exists, right? What is going on, guys? Welcome back. That's like the typical thing I say. Today, we will dive deep into support vector machines. So let us get right into it. There you go. Additional settings. I cannot choose an emotion, but let's see if it does that in a decent way. I actually tried this with the previous replica, but this will take some time, I guess. So let us move on to Python in the meantime. So let us now take a look at how we can use all of this in Python. For this, I'm going to build two very minimalistic Flask examples. One is going to be a live call, so we're going to embed the live call in our Flask application. Before that, we're going to be able to provide some context in our Flask application again. And the second example will be a video answering service. So we're going to ask a question and we're going to get a video answer using our persona. So I'm going to start by setting up the environment. You can do that with ordinary pip or virtual environments. I'm going to use UV. So UV init, UV add Flask, and also requests OpenAI and python-env. Now, if you don't use UV, you just go pip or pip3 install in the same packages: Flask, requests, OpenAI, python.env. And the most important thing now here is a .env file. So you want to create a file called .env. And in here, you want to have two things, especially for the asynchronous video answering. You want to also have an OpenAI API key. This is only for the video answering. Here you put your OpenAI API key. But what you need for both examples is a Tavis API key. And of course, where do you get this from? You go to API keys down here, and you create a new API key. Let's call this tutorial key, create API key, and then just copy and paste here. Now, I'm not going to show the OpenAI API key, but once you have this done, you close the file, you save it, that's it. Then we're going to go to our main.py file. We're going to remove all of the code here, and we're going to import OS. We're going to import requests. We're going to import actually from.env import load.env. By the way, for the auto completion, I need to briefly activate my virtual environment. And also from Flask, I want to import Flask for the application, request for handling requests, and render template string for rendering HTML here directly in the file to keep it simple. Now, I don't want to type out the HTML stuff, so I'm going to copy paste it. But first of all, we're going to load the environment variables here from the .env file. We're going to say Tavis API key is equal to os get env and the same name. Then also we're going to say replica ID is equal to and persona ID is equal to. For this, of course, we go into our replica library. We just click on the ID here and we paste it here as a string. Same for the persona. You go to the persona library and you click on the AI tutor. We click on the ID here and we have our persona ID. So let's move this away again. So once we have that, we're going to define the headers. The headers are important for authentication. It's a dictionary, and the important field here is the x-api-key. This is going to be our API key, and then the content type is just ordinary stuff. So content type is going to be equal to application/JSON. Finally, the last constant is going to be the API itself, so the API URL. And that is going to be https://tavisapi.com/v2. Now, as I said, I'm going to copy the HTML. You will find a link to the code in the description down below, but I don't want to spend too much time here now typing HTML stuff. The important thing here, the only important thing here is, first of all, the form. So here in the form, we just have a basic text area where we can provide some context. We can then click the button to start a live call with that context. So that is the submit button. And then here we have an iframe. If there is a conversation URL, we have this iframe that allows for camera, microphone, and so on. And it has the source conversation URL. So this is important programmatically, the form and the iframe. The rest is just styling and the heading and so on. But that is the central part here. Now with this, we create now an application, Flask __name __, and an endpoint, which is an app.route, the default route, the /route, with the method supported being get and post. And then we have index here as the endpoint. And we're going to say conversation URL is going to be none by default. And then we're going to say if we have a post request, so if request method is equal to post, then basically we submitted some context and we want to return now the iframe. So we're going to say the context is equal to request.form.get the field called context. By default, it should be empty if nothing was provided. We're going to strip it of any white spaces and new lines. Then we're going to say the body or the payload that we submit to the API is going to be persona ID is persona ID. Then we're going to say, actually, let me do that in one. Replica ID is going to be equal to replica ID. And then if context was provided, we're going to say body, and it's going to be the conversational _ context. This is what the field is named. That is going to be the context. Then we're going to post to the Tavis API. So we're going to say response is equal to request.post, actually requests with S because we're using the library here, .post, and a formatted string. First of all, the API itself /conversations like that. And then we're going to say headers is equal to headers. JSON is equal to the payload, so the body. And we have a timeout of 60 seconds. That is the response. And then we're going to say here response raise for status if there's a problem. And then we're going to say conversation URL is what we get as a result. So we get response.json.get, so JSON object get and then conversation URL, and that is what we're going to render now into our HTML file, into the iframe here. So we're going to say return render template string HTML, and we do that, by the way, outside of this if statement. So we do that in all cases, HTML, but the conversation URL is going to be the conversation URL. So if this is a GET request, we just have it at none. We render the HTML without the conversation URL. Otherwise, we get it from the API and we render it into the page. Final piece here is if underscore underscore name underscore underscore is equal to underscore underscore main underscore underscore, then we want to run the application, debug being equal to true, and that's basically it. So I can close this now and we can run this main.py, open this in the browser, and now here I have this application. I can provide some context. I don't know, today we talk about the mathematics of linear regression. So I can click start live call, and hopefully this is going to render now a live call into this website. There you go. I can allow again to use all my stuff here. Let's go join. Hey there.
Hey, how's it going? Ready to dive into the world of linear regression?
Yeah, so it seems like you're working. Can you explain to me the basic concept of linear regression in a nutshell? Very, very short sentence.
Sure. Linear regression predicts a continuous outcome by finding the line that best fits your data.
Perfect. So this seems to work. That is how you could do that. If you have an AI tutor or any other replica, persona, whatever, you can just embed it in a live call in your application, offer this as a service, for example, whatever you are doing with this feature. Now for the second example, what we're going to do is, first of all, we're going to replace the HTML part here. We also don't need a persona because we're going to just generate a video answer. So we're going to get the text from OpenAI directly, which means we're going to delete the persona ID. We're also going to import here, in addition to all of this, the OpenAI package. So import OpenAI. We're also going to create an OpenAI client. So we're going to say client is equal to OpenAI. Actually, sorry, we need to say from OpenAI import OpenAI like this. That is automatically going to load the API key because this is looking for an OpenAI underscore API underscore key. So it's going to find that automatically. And besides that, we need to change the approach of our application. So let me add here the new HTML part, which is going to be this time provide a question. The question is going to be taken, fed into ChatGPT or GPT-4o to be precise. And we're going to then get the answer, send it to Tavos, and then get a response once we have it. So how it works is we have a form here, which is method post. So I can ask a question. This is going to send the answer to our endpoint. And then we say if there is a script, we show the script. So then we get the answer script basically, so the text answer. And then if there is a hosted URL, what we get here is we get a video with the controls that say, okay, here's the hosted, or this is the source of the hosted URL. So we're going to render the video into the page. Otherwise, we see here that the video is rendering and we should refresh later on. That is the HTML blueprint or structure. Now we need to write the code for that. So for that, we're going to remove all of this here and we're going to say script is equal to hosted URL is equal to none. So we're going to initialize these two as none by default. We're also going to say video ID is equal to none. And then we're going to get our response from the OpenAI API. So we're going to say response is equal to client.responses.create. And we're going to just submit a basic conversation here, like we're used to with these language models. We're going to say model is equal to GPT-4o. You can, of course, change that if you want to. And then the input to that model is going to be just a conversation, so a list, and the list will contain dictionaries with the fields role. The first one is going to be the user, or actually the system prompt. We're going to say content, and here we're going to say you are an AI tutor teaching students stuff. in a simple way. Yeah, not the perfect prompt, but let's go. And then the user will ask a question, and the content of that question is going to be the result of getting a post request. So actually what we want to do here is we want to say if request.method is equal to post, same as before, then we'll want to get the actual user question that we want to answer here with this model by saying request.form.get, and the field is called Q with a default of empty. I'm going to strip it again here, and that is going to be the user question. That is what we put here into the conversation. So this is how we ask GPT-4o directly. Then we're going to get the script as a result. So we're going to say script is equal to response dot output text or empty if this is not present. We're going to strip that as well, and that is what we're going to feed now to the Tavos API to generate a video with this text that is provided by GPT-4o. So we're going to say create is equal to requests.post. We're going to post again to the Tavos API. So we're going to say here formatted string API/videos. The headers is going to be headers, same as before. Now we do need to provide a JSON body here in order to specify what replica we're using. So I'm going to provide here replica ID. That is going to be our replica ID. We don't need a persona because, again, we're just feeding in text. Then we, of course, need a script. So something that can actually be turned into a video. So script is going to be equal to script. And then we also need a video name, tutor, and then underscore. And for this, I need to import the time module. So I'm going to say here import time. I just want to have a timestamp. So basically the integer of time.time, like this. Very simple, just so we have a unique timestamp because we're not going to submit the same request or two requests in the same second. So that is the JSON part, and then we can also specify a timeout. Now, the timeout is not for the video creation. The timeout is for getting a response to this request, so you should get something quite quickly. The video generation can take longer, but you getting a response should happen quite fast. So timeout is going to be 60. That's fine here. And then we're going to keep asking if the video is ready already. So first of all, I'm going to say raise for status again to get an exception if there is a problem with the request. And then I'm going to say the data is what we get as a result here. So it's going to be create.json. And from this data now we can get the video ID, we can get the hosted URL. So I can say video ID is equal to data.get video ID, like this. Same with the hosted URL. That is also part of the data here. And then also the status. The status can be ready or it can be not ready. So get the status, and by default, I'm going to just return cute. So, of course, status here. That's the idea. And now we're going to keep asking, are you done? Are you done? Are you done? So we're going to say for placeholder in range, we're going to ask, let's say 100 times, just so we cannot time out here. I'm going to say if the status is equal to ready, so if the video is done, then we're going to break this loop. Otherwise, what we're going to do is we're going to sleep for 5 seconds, and what we're going to do then is we're going to refresh the data. So we're going to say got is equal to requests.get formatted string API/videos/video ID, which of course we put into curly brackets. And we're basically asking if this is already present. So headers, timeout for this one also 60 seconds. And we're interested in the JSON result. So this is what we now pull from the API, and then we update the status. We say the status is now got.get, and status, the default is the current status. And the exact same thing also with the hosted URL. And then finally, all we have to do is we return render template string HTML, script is equal to script, hosted URL is equal to hosted URL, video ID is equal to video ID. That should be it. If I didn't make any mistakes, that should work now. So let's close this. Let's go and say, in my case, uv run, or actually I'm in the environment, so I can say Python 3 main.py. Open this in the browser. I get an exception because we did not return a valid response. Maybe my indentation was problematic. I think so. There should be one more tab to the left. Let's try again. There you go. AI tutor to video. I can say, I actually tried this already, so let's delete that. What is linear regression in a nutshell? Answer in a single, very short sentence. Keep it extremely concise. The only reason I'm writing this is because I want to get an answer in a short amount of time. So I'm going to say now here, answer. What this is going to do is it's going to send a request now to GPT. GPT is going to answer it. It's going to give me basically a text answer. I'm going to take that, feed that to Tavos, and then I'm going to generate a video. Once the video is generated, it's going to be shown here in my application. And by the way, this is of course now very simplistic. You can add some more animations here, but you can also go to Tavos, to my videos, and you can see how this is being generated here. So if you want to track the status in real time, 37% here. You can also just go here to video library and see when it's done. There you go. It seems to have received the answer. So now you see here, linear regression predicts the relationship between two variables with a straight line. Now I get the video here. Okay, so actually I did a quick fix because what we get as a result is not the video URL itself. It's a link to the video, but this is actually a website where we have the video embedded. So to fix this quickly, I basically changed the video tag to an iframe here again, and now we have here the video.
Linear regression predicts the relationship between two variables with a straight line.
Yeah, so that is the video answer. Again, how do we fix that? You will get the corrected code, of course, but how do we fix that? We just go into the main PY, and instead of saying video here, to keep it simple, we just say iframe and then iframe. That works without a problem. This is what it looks like then. We get a script and we get the video
Linear
answer.
regression predicts the relationship between two variables with a straight line.
There you go. So that is how you can turn yourself into a tutor or anything else, a narrator or whatever you're trying to do, motivational coach. You can do that. You can embed that into your website. You can have live calls and you can build applications around that. So maybe you want to build a SaaS application where you have tutors. You want to do some more fine adjustments. This was now a very minimalistic example, or two very minimalistic examples. But yeah, this is how you can do that with Tavos, how you can clone yourself and turn yourself into an AI tutor. So that's it for today's video. I hope you enjoyed it and hope you learned something. If so, let me know by hitting a like button and leaving a comment in the comment section down below. Of course, also don't forget to check out Tavos, the sponsor of this video. This is what we used here today to create a replica, in this case of me, and turn this into an AI tutor that we can use in Flask. Make sure to check them out. Link is in the description down below. Also, the code for this video is in the description down below on my GitHub. Besides that, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching. See you in the next video, and bye.